The rig for our hand is pretty simple and fairly straightforward. There's just lots of repetition. So what we'll have is a simple bone hierarchy to represent the finger. We'll have our proxy geometry, and those bones will be driven by a series of controls. So when we rotate those, they rotate the bones. And then our parameter pane will also be very simple. We'll group the hand parameters in a little group box here. We'll have a geometry display, a bones display, controls display. The hand rotation will also drive the twist that we were talking about in our arm, so we'll implement that as well. So I can rotate the wrist through that handle, but then if I rotate in Z, you can see that I get this nice twist that moves up the forearm. So we'll implement that as well. And then the rest of the controls are essentially just an interface on a number of expressions. So we can do things like curl all the fingers at once. We can splay them, sort of move them side to side. We can fan them back and forth. And then we can also flex them. And then these parameters are repeated for each of the fingers, the thumb, index, middle, ring, and pinky. So you can see the index finger has curl, splay, fan, and flex. And then we have parameters for the individual rotations down there. And then also for the thumb, but it doesn't have a fan or a flex. It just has curl and splay. So pretty simple, pretty straightforward, just lots of repetition, and let's get started. To begin our hand rig, we're going to turn off the spine proxy and spine controls, head proxy, head controls, and our arm proxy and our arm controls, but we'll leave the bones on. And then we'll turn on our soldier body so we can draw these bones correctly. And what we want to start with is a hand bone, and we could attempt to draw it here in the hand using the various bone drawing options. But probably the easiest way to get exactly what we want is to simply start in the network with a null. We'll call that, so it's sitting down at the origin. We can make it much smaller. And then just put a bone in the network. So it will pop down to the origin, and because these two are in the same spot, we can just wire them together. And so now it's as if we've drawn this bone at the origin. For starters, we can make its length much smaller. And then to position it, we can just take the left-hand bone root and make it a child of left arm bone 2. So now it pops itself at the root of that bone. We can then take the length of that bone, so select left arm bone 2, go to the bone length, just copy that value. And now down in our left-hand bone root, we want it to sit at the tip of that bone, so we want to be in a negative direction. So we can paste that left arm bone 2 length value and then just negate it. So now we know that this null, this left-hand bone root, is sitting exactly at the tip of that bone. And then, just as we did with the arm bones, we want the rotation of this bone, which we should call left-hand bone. We want its rotation to be in the x axis, pointing down, and we want it to be positive. So right now it's oriented in the same way as the lower arm bone. So we can change that by selecting the root and moving that like that. So now when we select the left hand bone and we rotate in X, we're getting a positive value here. So that's what we want, and now we can just align this with the hand geometry. And if you make this bone and you can't see it through the geometry, you can right-click and use the flag X-ray, and that will turn that into an X-ray object and you can see through the geometry. So again, with the root selected, we're just positioning this the way that we want it. We can select the hand bone, go back to the bone length tab, and just make it about that long. That should be good. We can turn the selectability and display of the root off. So there's our bone. We can give it a color if we want to. Let's make it red. So there we go. And now, select the left-hand bone root, turn on keep position when parenting, and just sever that connection. So now it's as if we drew this bone exactly where we wanted it, right in the middle of the hand. But it's good. And now we can add a control to this hand bone. And once we have that control, we can finish up our arm proxy geometry. So to do that, we'll go back to our rigging tab, select our hand bone, FK control, left hand bone is our proxy, or our prefix, I mean, which is what we want. And now we get our control hierarchy. So we have an offset, an auto, and a control. And for this control, I'm going to leave it as a circle, but I'm going to make it much smaller. Maybe I'll turn on the IK control of the arm just to compare the sizes. That should be good. And what we'll do next is we'll constrain the hand bone root into the bone hierarchy of our arm, and we'll do the same for our hand bone offset, so that when we're in FK and our arm rotates, it'll bring all of these controls for the hand along with it. To constrain our left hand bone root, we're going to be using a parent blend. So with that one selected, we can select parent blend, and we're going to use a simple constraint. We're going to be using the transform, but not the rotation. So we turn these three off. We'll be using keep position, and then we can select the lower bone as the new parent. So accept selection, and we're dumped into that left hand bone root constraints network. You can see that we're getting world space, getting the parent space, getting the left arm bone 2, and we're computing the full transform, but then the final parent just has translation and scale, so we're not sending rotation out. And we can see the effect of that. We can turn back on our controls parameters, our control parameter for our arm, and if we select the IK and we move it, you can see that our hand bone is following with the IK. And if we move that to FK and rotate, you can see that the hand bone is also following. But you'll notice that it's just transforming. Its orientation is remaining local. So we'll deal with that in a second. We also want to move this hand control, the hand bone control. So we'll set up the same constraint. So with the left hand bone offset selected, we'll go to a parent blend, simple, again, just translations, turn off the rotations. It's asking us to select that again, so we'll say accept selection. It's asking for a new parent, which is the arm bone. Accept selection. It dumps us into the left hand bone offset constraint network. And again, that parent is just sending out a transform and scale. And we can see that now when we are we in IK or not? So let's turn IK back on. When we move our IK control, that circle hand control is also moving. And when we turn the arm to FK and rotate, it's also moving. So that's what we want. Let's turn IK back on. And now what we want to do is constrain the rotation of the hand bone to the rotation of this hand control. So select the hand bone, parent blend. We're going to use a simple constraint. We're going to turn off translation and turn on rotation and turn off scale. It's asking us to select a new parent object, so we'll select the hand bone control, right click, accept. And now in our hand bone constraint network, we have the very similar constraint network, except the final transform is just sending rotations. So now if we select that hand bone control and rotate it, we're rotating the hand bone. And when we rotate in X, we're getting a positive value. Now that we have our left hand bone control hooked up, we can use its Z rotation to drive those twist bones. So to start, we're going to turn off our soldier body, and we're going to go over and find our proxies that we made a little while ago. Bring those down. We're going to need to put them near the upper and lower arm bone, so I'm going to rearrange this network a little bit. Take that stuff and put it there. Stuff down there. There. So we have this series of proxy geometries, and now we need twist bones inside each of our upper and lower arm bones. So for the moment, turn these off. And if you'll remember, we installed a script called split bone, and we're going to use that to create new bones within each of our upper and lower arm bones. So I'm going to select the left arm bone 1. I'm going to hold the shift key down, then click split bone. That gives us a split bone prefix. And I'm just going to use split, or actually, let's use twist. You can use whatever you want. Twist sort of makes more sense in this case. And I'm going to say OK. Now it's going to ask me the number of bones that I want. And the default that I've set here is at 4, and that will be fine for these twists. And so now we have to try and find out where these bones are. So let's move that left arm bone 2 out of the way. Move these out of the way. And now we've built twist bones for our left upper arm. And before I do the left arm bone 2, I'm going to rearrange this network much more. It's a little too crowded. There we go. So left arm bone 2, hold shift, split bone, twist, 4. Now we have our twist bones. So now we can hook up the proxy geometry for our arm to each of these bones. turn them on and make sure that we'll have to cycle the lock here because now that we've attached them to the bones, the actual geometry is floating out over here. So we go inside, control click on the lock flag, then just lock it up again. You can see that that popped right where we want it. So we have proxies for our twist bones, and you can see that if we twist one, it twists like that. The upper arm. And you could put that shoulder proxy as a child of this first bone, or not. Depends on what you want to do. In my case, I'm just going to leave it attached to the shoulder for now. So now that we have the proxy geometry and we have the controls that we need, we can use this twist expression shelf to set up some expressions on our twist bones so that when we twist this hand control in Z, we'll get a nice twist distributed up the forearm, and then from the shoulder down to the elbow, and then at the elbow up and down the arm. So we'll start up here at the shoulder, and to use our twist expression shelf tool, we just hit twist expression, and we're prompted, see down in the status bar, select the first and last control objects. So in this case, that's the shoulder, or rather the upper arm rotation, lower arm rotation. Accept that selection, and now we're prompted to select the bones in order. Right click and accept that selection. And now you can see that these bones have an expression built into their rotate Z parameter. So we can test that. If I select the upper arm control and rotate in Z, you can see that we're getting some nice twist there. I can select this one, rotate, and there's twist as well. So now we'll do the lower arm. So again, twist expression, we're prompted for the first and last control. So the first control will be the lower arm FK control. The second control will be the hand rotate control. Accept that selection. And then the bones in order. And now we can test that. So if we rotate from the elbow, we'll get twist in the upper arm and in the lower arm. And then when we rotate our hand, we'll get a nice twist in the forearm. Great. Before we move on with the hand, I went in and cleaned up the network a little bit more, and I added these network boxes around the major sections of our rig. So we have the spine here, the head and neck, and the arm. And then I also went through and added the missing node groups for the left arm and the head and neck. Made sure that those were all accounted for. And again, you can get to that by Shift Z, and that will bring up this window. And then I added the display expression for our proxy geometry for our arms, so that if the G display is 1, then they'll be on, otherwise they'll be off. So now we can use our left arm geometry display to turn all of that geometry off, or proxy, and off when it's in deform. I also turned off the display of the twist bones, and that's not controlled by this bone display. So you can see that if bone is on, we can't see the twist bones. And attach the control displays properly. Also, right now we're in IK mode, and you can see that by the left arm FK-IK blend is set to 1. If I move this toward FK and I pass 0.5, you could see that the IK controls of the arm turn off and the FK controls turn on. And that 0.5 is just kind of an arbitrary value. And where I did that was in the FK controls. I bring up the expression editor with Alt-E. Can bring this out. So I'm saying that if the left arm control display is 1 and the left arm IK-FK blend is less than 0.5, then this should be 1, on. If it's greater than 0.5, then it should be off. And you can see that if it's greater than, that means that we're going toward IK. So this will turn off the FK controls if we're less than 0.5. And then I did the opposite for the IK controls, where I'm saying greater than 0.5. So some simple expressions to drive whether or not either set of controls is on. All right, having done that, we can move on with the hand. Putting bones in hands can be difficult. Hands are not symmetrical, they're not lined up with anything, they're all wobbly and weird. So really there's no trick to doing this. The only thing you can do is just dive right in and start doing it. But there are some things that we can do that make it a little bit easier. In Houdini 16 and 16.5, we have in the Bones tool some placement options. And by default, it's view-based, but we also have normal-based and freehand. And what these view and normal-based modes are is that the Bone tool will detect the geometry underneath our cursor. And so when we click and create bones, it will use the view plane and try and find the middle. So it'll detect this first surface here, and then it'll detect the back based on this view direction. And it will find the value in the middle, and that's where it'll place the bones. And then the normal-based method will detect the surface normal, either at the front and then again at the back, and find that middle distance. And then freehand is just freehand. It won't care about anything in the geometry. So what we can do is we can give this a try with view-based on the thumb. And if we just sort of line this up, we might want to go into orthographic mode by turning off perspective and just trying our best to line this up and then give it a shot. So 1, 2, 3 bones, finish drawing. So we get our bone chain. And if we have a look at it, we can see that it's not what we want. The bones have been placed correctly for where we clicked in the middle of the geometry based on that view plane. I'm going to come out of orthographic and back into perspective. But they're not lined up with each other very well. You can see we have this little bend here. And so that's not going to be great for our rotations. If we rotate these, you can see that they kind of go all squirrely. So that's no good. And normal-based placement will end up being something similar to this. So what we can do is we can try using one of the other features of the Bones tool, and that is the divisions parameter. So again, I can go to view-based. I'll just go back to orthographic. And what I'm going to do is I'm going to click once here, and instead of drawing 3 bones, I'm going to come out to my end position, and I'm going to use my scroll wheel to make 3 divisions. So now these bones will be lined up with each other. Finish drawing. So now I have my bones. I'll come out of ortho view back into perspective. So now these are nicely lined up, which is what we want. But you'll notice that if we select our chain root and we go to the transform tool, because we want to better position and orient these bones, this root is lined up with the world space. So that's not too bad for repositioning, but when we want to orient this, it's kind of, it's a little bit difficult to get the kind of weird angle that we need to conform to this thumb. So we're going to take advantage of our split bone tool, and what we're going to do is, again, back into orthographic just to help us out a little bit. Go back into the bones tool, view based, and I'm just going to start it here. I'm going to reduce this back to one bone and click right there. So now I have one bone that is approximately where we want our 3 thumb bones to be. If I come out of using escape to come out of the bones tool, I'm going to select this bone and I'm going to control click on our split bone tool. I think it's control click, we'll find out. We can leave this at split. We have to rename these nodes anyway. I'm going to say OK, and I want, instead of 4, I want 3 bones. So now we get this separate chain, and we can turn the display of these guys off. I'll just take this, make it a little smaller, easier to use. Come back into perspective mode. So now we have 3 bones that are lined up with one another, but we also now have a root that is oriented with our bones. So now moving and reorienting this chain will be much easier. So before we do that, we want to check that our rotations are going in the right direction. So I'm going to select all 3 thumb bones and just rotate them positive. So this is going backwards. So I'm going to take our root, put 180 in rotate Z, and then clean that transform. And now when I select those bones and I rotate an X, they're going forward and I'm getting a positive rotation. So that's what we want. Let's set that back to 0. And now I can take this root and position this chain right where I want it. So I think a little bit over here. And then I think for rotation, if you find when you're rotating something and you want to be quite precise, it's sometimes difficult when selecting an individual axis. You get kind of a difficult little wobbliness. What you can do is, with that selected, if you move your mouse very far away from the position of rotation, way out here, you can get a much finer control over that rotation. So I'm going to place that right about there. Maybe move it a little bit more over. So that's pretty good. But you'll notice that our bones, while they're aligned properly, they're not long enough and they're not in the right positions. But having oriented the whole chain with this root, now it's very easy to simply select that first bone and rotate it just how we want. We can go to the Bone tab on the bone and just increase that length a little bit to push that rotation right to there, which is pretty good. And then we can select the next bone and rotate it down, maybe make it a little bit longer. And we can select that last bone, rotate it just a little bit, and make it a little bit shorter. So now, since we've only rotated each of these bones in X, they're still perfectly lined up. And now we can just select all three bones, go back to the Transform tab, and we want to get rid of these rotates, so we can just say Modify Pre-Transform, Clean Transform. So that's about the best trick for making finger bones that I can think of. It's pretty simple and straightforward, but you get a lot of control, which is what you need. And the key thing to remember with finger bones is that no matter what your geometry is, unless it's really crazy, some sort of fantasy creature or something, the most important thing for your animators is that these rotations are consistent and predictable. And so that's why we want to keep these all nicely lined up. And then for naming, I'm going to start naming these left hand, and then this is the meta root 0. And we're going to use numbers to name our fingers. So the thumb will be 0, the index will be 1, middle will be 2, ring finger will be 3, and pinky will be 4. In our interface, when we get to this, we can call it thumb and pinky and whatever we want. But it doesn't really matter. We don't need to have these kind of readable names for our nodes. But for scripting, it's much better to have use sort of numbers as suffixes. So that will be the left hand meta root. This will be the left hand meta bone 0. And then left hand prox. And this one will be called dist. And I'm using just the anatomic names for bones. And you can find that really easily. Just Google hand bones or go to the Wikipedia page, and you'll find something like this. So we have carpals, which are like the little weird bones in the hand. We have metacarpals, so all 5 fingers have a metacarpal. They have a proximal phalange. All of them have an intermediate phalange except for the thumb, and then they all have distal phalanges. So I'm using that convention. And now we can get rid of this early chain bone that we made. We don't need it anymore. And there is our thumb. So next we'll do the index, middle, ring, and pinky finger. An optional step when rigging a hand is to create metacarpal bones in addition to finger bones. They're not always necessary. It really depends on the character that you're doing. For our character, I'm going to create metacarpals. And we could go through the same kind of process that we did for the thumb, but I'm just going to create a quick bone just down at the origin. I'm just going to go into the Bones tool. I'm going to put grid snapping on. Just do that real quick. So now we get a chain root and a chain bone. And I can take that chain root and parent it to the hand bone. Whoops. Before I do that, I'm going to take key position when parenting off. Go to the hand bone. So now it snaps up right where that hand bone is. You can grab the bone itself, make it much, much smaller. And now with the chain root selected, I can escape out of the Bones tool. Now I can offset it from the wrist. Whoops, still have snapping on. Turn that off. Turn this root off. So I want to put the metacarpals at the wrist, but offset from that wrist rotation spot. So you can see in our little picture of our metacarpals, oftentimes people will have a set of metacarpals that all rotate from the same spot, and they sort of fan out like that. But that's not very good. You want to spread them out a little bit. So by parenting their root to the hand bone, we have them aligned properly. And so now we can just spread them out a little bit and can rotate slightly. Then go to the bone itself, go to its length, and about there. And then we'll check the rotation to make sure that when we go down, we want to go in the positive X. We're getting positive X here. That's what we want. Maybe that. Great. Now I'm going to name these in the same way that I named the thumb. So left hand meta root 0, this becomes left hand meta root 1. This is left hand meta bone 0, bone 1. And you'll notice that all I did there was copy this name and paste it into this name. And so it tried to name it 0, bone 0, but there is already a bone 0. So Houdini will automatically increment the number. If a known name ends in a number, it'll increment it. So we get that automatically. And now what we can do is we can simply select these two, copy and paste, and now we get perfectly incremented metacarpals. And so here we just have to move them over into their correct spots, and then we can attach finger bones to these chains. All right, so I've done exactly that. I've duplicated the left hand meta 1 metacarpal to meta 2, meta 3, and meta 4, and then I oriented them to point to the position of the finger rotation. I modified their length a little bit, and then in their positions I kind of gave them a little bit of a curve just to reproduce that slight curve that a hand has. And so next what I'm going to do is I'm going to do exactly what we did with the thumb. For each finger I'm going to draw a single bone from this point to the tip of the finger, and then I'm going to use my split bone shelf tool to create those 3 bones. I'm going to make sure that their rotations are positive in the curling in motion, and then I'm going to position them properly. So I'll come back when I've done that and show you what I've done. So I've finished all of the fingers, and as I said earlier, all I did was use the same technique that we used for the thumb. I created a single bone chain from the root of the finger to the tip. Then I used our split bone tool to split that single bone into 3. I made sure that my rotations were correct. I repositioned using the rotation of this, well, first with the root, then rotated this bone, increased its length a little bit, rotated this bone, modified its length, rotated this bone, modified its length a little bit. And then actually what I did was just in the network, I took a bone chain and using Alt, held Alt down and then clicked and dragged to create a new bone chain. And then I just parented the root to the next bone so that I could quickly reproduce that. And then I just had to go in and modify each of these individually. So we can go back to our thumb meta root. It's got keep position when parenting on. So we can parent that in to the hand bone, like our metacarpals. And now we can test our rotations. If we grab all of our finger bones, and in the rotate, we can rotate them in. You can see that they're all rotating into the palm quite nicely. So now we just want to go through and clean some of this up. So I'm going to select all of the bones, shift select those, shift select the fingers, and in the transform, I'm going to say modify pre-transform, clean transform. On the bone tab, I'm going to go into this rest angles, and I'm just going to put zeros in here. These numbers can get a little bit modified as we are doing things. We'll talk about rest angles later on when we go into capturing, but just to clean all of this up. And then all of these bones, I'm going to turn off their selectability, or make sure that they're turned off, so that I can't select them in the viewport. And then all of these root nodes, I'm going to select, I'm going to turn off their selectability and their visibility. And I can just clean this up a little bit. And now I can actually test to see that our wrist control, if I rotate that, it brings all of the bones with it. So that's good. And then next what we're going to do is we're going to make the proxy geometry for all of these bones. And then after that, we'll set up our control hierarchy for each of these bones. I've gone ahead and made proxy geometry for our hand and fingers. And again, that was making a group on our original geometry and then object merging it into a separate object and then locking it in a null. Then I parented each of those pieces of geometry to their respective bones, and I turned off the selectability flag. And so now, when we rotate our bones, our proxy geometry follows along, and we're ready to make our controls. So we're going to use our FK Control shelf tool, and it's as simple as selecting a bone, hitting FK Control. It'll give us the default prefix, which is just fine for what we want. We can hit OK. And then we get a series of nulls, our offset, our auto, and our bone control. And the controls by default are coming in at 1 unit, which is in Houdini by default 1 meter. But I think I'd like to change that to something a little more reasonable, maybe 0.15. Let's see how small that is. Let's try 0.1. So that's a bit better. We can go ahead and change those later if we want. So I'm going to edit the tool itself, and the FK Control object has a geoscale, and that's being set here with this variable control size, and that's being defined up here. So I'll put that at 0.1. I'll apply and accept. So this is the metabone control. I'll select the next one, FK Control. And so now it's coming in at a much more reasonable size. Distal. So there are the controls for our thumb. I'm going to pause the video and do the same for the metacarpal bones and for each of the finger bones, and then I'll come back and show you what I've done. Okay, I've gone and made controls for all of the metacarpal bones and all of the finger bones, and then I've parented the offsets of all the metabones to the hand control, and then just parented each bone's controls in order. So metabone control is the parent of this offset, this control is the parent of that offset, and so on. And then for the metacarpals, by default the control will come in way up here at the root of the bone, which is fine for the rest of these fingers, but for the metacarpals they all get jammed up here at the wrist. So what I've done, as you can see down here, is I selected the control and just moved it in Z along the length of the bone until it got to an area that I liked. In this case it was 0.75. I can just clear these out. And then I moved it slightly up in Y, I think about like that. And then I need to move the pivot back to the root of the bone because I don't want this control pivoting from here. So it's easy enough to take these values. I can just copy this parameter and come down to pivot translate, paste the values, and then put their opposites in. So now when I select this control here in a much more easily accessible place, it's still rotating from the root of that bone, like that. And then again, just parent all of these together. And there we go. So now we have a full collection of controls, which are a child of the wrist control here. And then each of the metacarpals will move, and it will bring along all of the finger controls. Grab all of these, see that we're moving nicely. Next, we'll set up a series of constraints between the hand controls and the hand bones themselves. To create our constraints, we're going to select one of the bones. I'm going to go to our Constraints tab, and we're going to use the Simple Blend, set to Simple. We're just going to select Rotation, and we're going to keep position after. So it asks us to select Object to Constraint, or to create Blend Constraint. So we select our bone, accept that selection, and now we're prompted to select the target object. I'm going to select our Hand Metabone 0 control, accept that selection. It drops us into the constraints network inside the bone object. You can see that we're getting the world space position of the bone, we're getting the position of the bone control, we're performing a simple blend, and then we're maintaining the offset. Even though there isn't an offset in this case, it's nice to have. So now we can select that control object, and we can rotate our bone. So I'm going to go through and do all of these, all of the thumb bones, metacarpals, and all the finger bones, and I'll come back when that's done. So I've finished constraining all of the bones to their respective controls. So now I can select those controls and animate our fingers. I also went into the network and cleaned things up a little bit, made it a little more organized. I also created our node groups for the hand bones, the hand controls, and the hand proxy objects. On the hand proxy objects, I selected them all and used our Lock All shelf tool to lock its transforms. So I did that for all of the proxy objects. I made sure that all of the nulls that we aren't using have their selectability and display flags turned off. And now we're going to go and start building our parameter interface for our hand. And that will sit right below the left arm parameters in our left arm folder. And then once we've done that, we're going to mirror all of those controls so that when we mirror our left arm, all those controls will hook up automatically because they'll be looking for all the right names. So to begin making our parameters for our left hand, we're going to start in the left arm folder. I'm going to make a new folder, call that left hand. To make it a simple folder, and then we're going to select our geodisplay, bone display, and control display from our arm, duplicate those, drag them into the left hand. Now we can rename these. And now we want to create basically a hand rotation. We'll promote this hand rotation, and then we're going to create a series of sliders to drive a curl, a splay, a fan, and a flex for our fingers. So to start that, we'll take our left hand bone control. We'll promote the rotation. So we'll call that left hand bone control, left hand bone rot. And then we could, if we wanted, have these automatic curl and splay and flex go from 0 to 1 or 0 to 10. I'm going to do 0 to 10, or sorry, negative 10 to 10. So I'm adding a, not a label parameter, a float parameter. And I'm going to call this curl. And come down here to the range section. I'm going to turn on range. I'm going to make this negative 10 to 10. And I'm going to turn on the lock for both sides. So that will restrict this slider from -10 to 10. So select left hand curl. I'm going to hit duplicate for splay, for fan, and then for flex. I'll go in and rename these. So these controls, the curl, splay, fan, and flex, will drive all of our fingers. But we want some of these for each individual finger as well as controls for their rotations. So I'm going to create another folder. I call this left thumb. I'm going to duplicate it for index, middle, ring, and pinky. Rename these. And now I want to take, for the thumb, I think we just need, curl and maybe splay. So I'll take curl and splay, duplicate those, put them into the thumb, and now I can say left thumb. Thumb splay. And now I want to grab the rotations from each of our thumb controls. So I'm going to select left hand meta bone control, throw that rotate in there, call this meta rot. Select the proxy. Copy this. And then I'll take the distal. Now if I hit apply, you can see that for these controls, their rotations have been promoted. We can take a look at our parameter pane now. So underneath our left arm, we have a left hand group. We have our display of our controls, bones, and geo. We have the left bone rotation. We have these left hand curl, splay, fan, and flex that go from -10 to 10. And then we have a thumb, index, middle, ring, and pinky. And the thumb has a curl and splay that go from -10 to 10. And then we have the meta, prox, and dist rotations. So what I'm going to do is pause the video and I'll add the same to these 4 fingers. And then we'll hook all of this stuff up and then write some expressions so that these sort of global style controls will drive all the fingers. So I'll be right back. All right, I've finished adding all of the interface parameters for the hand, the thumb, index, middle, ring, and pinky. One change that I did make was that the left hand flex parameter used to go from -10 to 10, like the curl, splay, and fan, but I changed that to 0 to 10, and I did that for the index, middle, ring, and pinky flex as well. Then what I did was I went through and, just as we had done in our other sections, turned on the display flag of our proxy objects, and I went and stole that same expression that we were using before, that if the geo display is off, the display should be off. If it's on proxy, it should be on. And if it's on deform, it should be off. So I did that for all the proxy objects. Then I hooked up the bone display. You can see here it's off. I turned it on. And then I did the same for all of the controls. Off and on. For the curl, splay, fan, and flex controls, in order to sort of understand this without getting ourselves distracted, we're going to concentrate just on the pinky. And we're going to start with the splay. And the splay goes from -10 to 10. And when the splay is at 10, we want our pinky to splay out like that, about 20 degrees. And then when the splay is at -10, it can probably come in again around 20 degrees. We'll see how it looks. So the question then is, how do we map this -10 to 10 parameter to the rotation of our pinky rotation while keeping this parameter free? We want to leave this control open for our animators. And how we'll do that is by using the auto null just above our control. Because if we select that and rotate it, it's giving us the same result, but it's going to leave this guy free for our animators. So in order to see these things a little bit better, I'm going to select all of the auto nulls. And I'm just going to give them a different color in the network. I'm just going to give them this, maybe a pale red, just so we can see them and find them quickly. We're going to ignore the meta control for a second and just concentrate on this control at the knuckle. So we know that we want to, when we do pinky splay of 10, we want to rotate this auto null by about 20 degrees. So the first kind of obvious thing that we can do is we can take this pinky splay and just drag and drop it into the Y channel. So with that direct relationship, we do pinky splay of 10. So we want to, first of all, reverse these. We want to go, if we have 10 positive, we want to be going out. So the first thing we can do is just negate that. But we saw earlier that we want to go 20 degrees, not just 10. So what we can do is, if we hit Alt-E in a channel, we bring up the expression editor. And what we can do is use the fit function. And what this will do, I'll just sort of write it out in a basic form for you. So it's a fit, and it's a function, so we do the work inside the parentheses. We have a value that has an old min and an old max, and then it has a new min and a new max. So we're going to take a value that has an old minimum and an old maximum, and we're going to change those to new minimum and new maximum. So we're going to remap whatever that value is between this new range. And in our case, that value is this left pinky splay that has an old minimum that we know is -10, and it has an old maximum of 10. And the new minimum we want is, we think, -20. We'll try -20 and see how it looks. And then the new max is 20. And then we know that we want to reverse it so that when it's a positive splay, it's going to go out. So we just cut this. So now we have that, but for our value, we want to put in that parameter. So just to go over it again, we want this channel. So we're going to take this channel, the left pinky splay, that has an old minimum of 10 and an old maximum of, or an old minimum of -10 and an old maximum of 10. We're going to remap that value from -20 to 20. And then we want to negate it. So if we hit apply and accept, we can see if that worked. So again, left pinky splay. And that's exactly what we want. We go to 10, and we have -20. Go to -10, and we have 20. So that is the principle that is going to run all of this stuff for all these fingers. And then what we're going to do is just sort of layer different rotations and different fit expressions for all the various controls. So next we'll do left pinky fan, and this time when we go to positive 10, we want this control to rotate in the x-axis, and we want it to go in, let's see, maybe, let's say 35 degrees. So again, we'll not use the control, but we'll use the auto. We want to go in the rotate X direction. So we take left pinky fan, can drop that right in there. If we go positive, that's what we want, but we want, again, 10. We want to map this to, I think we said 30. So again, Alt-E, and we can say fit that value between the old minimum, which was negative 10, and the old maximum, which was 10, to the new minimum, we're going to say negative 30, and the new maximum of 30. And we can apply, accept, test that out. So right now it's at 30 because this is at 10. And if we bring that up to 0, or I guess 0 is 0, and negative 10 is negative 30. So that's our fan action. But what makes a fan is that these fingers all have different values. So this pinky is going to 30, so the ring finger should probably only go to about there, which is, let's say, 15. So we can do that right away because we know how to do that. So we'll go into this, we'll copy this, we'll go to our ring finger auto, and right inside rotate X we can paste it. So instead of left pinky fan, we can say left ring fan, and we know instead of 30, I'm going to do 15 and 15. So now if we go to our ring, left ring, and do fan, it's going to go up to 10, down to 10, and that's going to use 15. So if we put both of these on to their maximum, you can see that they're just staggered a little. And then for the middle finger and the index finger, we're going to use the exact same values, but we're going to negate them so that the middle finger is going to come out a little bit, and the index finger is going to come out even further, so that they do this fanning effect. And then when we go to the opposite way, these will reverse themselves. So I'm going to do that for the middle and index for the fan, and I'm going to do also the splay for ring, middle, and index. And for the splay, it's exactly the same thing. Our pinky splayed out by, find it, by 20 degrees, and then it splayed in by 20 degrees. The ring finger is probably going to go, maybe 10 degrees out and in. Middle finger will go 10 degrees out and in, but in the opposite way of the ring finger. And then the index will also go the same degrees as the pinky, but again, opposite. So I'll finish up those, and then I'll come back and show you what I've got. So I've completed the splay and fan for each of the fingers. You can see that here's the fan at negative 10 for each finger. So pinky, ring, middle, index. And if I go to positive 10, they reverse themselves. And then if I do splay to 10, they splay out. And then if I go negative splay in like that. So next we want to do curl. And curl is essentially the same thing. We're going to take the control, or rather the auto above the control, and we're going to curl it in, but we're also going to add the same amount of curl to each of these controls. So we get this kind of a thing going on. So we need to decide how much of a curl we want for each of these fingers. So if we take this pinky, let's say 65 degrees for that guy. Let's see what 65 looks for this guy. Yeah, 65, and then yeah, 65. So we'll remap for pinky curl. We'll remap positive 10 to 65, and negative 10 won't be negative 65, because that would be something like this, which is not natural. So we actually want to map negative 10 to something more like maybe something like that, negative 20. So let's see how we do that. If we take our auto control again, and we're going to go into rotate X, Alt E to bring up the expression editor. And the expression editor is nice that you don't have to stay all on one line. You don't have to keep adding and adding and adding and adding. What we can do is we can simply add and then go to a new line. And this is nice because we can separate out all of the different things that we're going to do. And it's much easier to read and much easier to edit when we need to. So we're going to do pinky curl, so we can just grab that whole fan expression and paste it in and change it to curl. So now we're doing negative 10 to 10, remapping it to negative 30 to 30. But we said that we wanted, I think it was negative 20 to 65. But this is probably not going to be what we want. But I'll apply it and accept it anyway, just so you can see what's happened. So our value for curl is at 0, but we've introduced a little bit of curl here, which is not what we want. We want 0 to be 0. So how do we fix this? Well, what we can do is we can break apart this little expression. So instead of mapping negative 10 to 10 and remapping it from negative 20 to 65, what we can do is we can take negative 10 to 0, and we want to remap that from negative 20 to 0. And then we can add that to a remap of 0 to 10 and 0 to 65. So instead of trying to do it all in one line, which we've seen doesn't work, we can split it up because we're taking just a portion of the full range of this parameter and remapping that. And you can get some pretty complex things if you want in there, but this is perfectly good for us. So we want to keep our pinky fan, but we're going to get rid of that curl, which doesn't work. So we're going to have a pinky fan influencing this node, plus this half of pinky curl, and then plus the second half of pinky curl. So let's see what that gives us. If we apply it, accept, you can see that pinky curl is at 0, and our auto rotate X is at 0. So that's a good sign. If we go pinky curl all the way up to 10, we can see that we've got 65. And if we go down to negative 10, you can see that we've got negative 20. So that's exactly what we wanted. And now all we have to do is take the curl and apply it to our other two auto nodes in rotate X. So Alt E, and replace the 0 with that same expression, apply and accept. And now you can see that at -10, all three of them are curled to -20. If I bring that back to 0, it's back to 0, and now it curls all the way up to 65. So I think that I'm able to use that same amount, -20 and 65, for all four fingers. So I'm going to apply that, and then we'll move on with the next section. I was almost 100% right that the -20 to 65 would be good for all of these fingers. It's pretty good. We could adjust them a little bit, make some of them a little more, some of them a little less. But for our purposes here, those values are fine. So again, we have 10, it's curled in, -10, it's curled out for all of these fingers. So pretty good. Next, we're going to do the flex. And the flex is a little more involved, but it's using the exact same expressions that we've used already. So when we flex this finger from 0 to 10, what we want this finger to do is to kind of, well, flex. So this rotation is going to go sort of negative, maybe about 30. The next segment of the finger is going to go 30 in the opposite direction. And then this guy is going to go about 30 as well. So the finger kind of keeps its same line from root to tip, but it bends up in the middle. So here on at our knuckle, what have we got here? About 30. So we can go back in again to our left-hand prox bone 4 auto in RX, and we can add. We can steal this, save us some typing. So now we want pinky flex, and this one is at about, what was it? -30. So 0 to 10 in our flex, because our flex parameter goes from 0 to 10. So flex 0 to 10, we're going to map that from 0 to -30. We can copy this, apply, accept. Let's put those back to 0. So now if we look at our knuckle of our pinky, that flex brings it up like that. So that's just what we want. And then both of these, oh, we can't do that. Do them one at a time. We're going to add the exact same expression, pinky flex 0 to 10, 0 to +30. And copy that. And paste that in here. So plus 0 to 10, 0 to 30. So now for our pinky flex, we go from 0 to 30. So it just flexes up like that. So those values may even be useful again for the other three fingers. So as I did before, I'll apply those values and come back. Now that we're finished with the curl, splay, fan, and flex for each of these fingers, we need to add in these expressions. And because these ranges are exactly the same, we can just reuse the same expressions that we used for the individual fingers, but instead of using, in this case, left pinky curl to drive these rotations, we can use left hand curl. And so I've already set that up on the pinky. I'll show you the effect of that. So we have our left pinky folder, left pinky curl. If we go forward, curls in, curls out. But now also the left hand curl will drive those rotations. The difference being that the hand curl will also drive the other fingers, not just the pinky. And as I said, because the ranges are the same and the values are the same, all I had to do for each of our auto nulls was I took this split pinky curl fit expression going from -10 to 0 and 0 to -10, and I just added it onto the end and changed pinky curl to hand curl. So now this parameter is going to drive the rotation here by these amounts, but also the hand curl control will drive the same rotations by the same amounts. So I just did the same thing to this auto control null and this one. And that will be the same for the splay, fan, and the flex. So I'm going to apply all of that to all the fingers. I'll come back and show you what I've done. And then we'll quickly just finish up with the thumb, which doesn't have all of the controls. It just has thumb curl and thumb splay, but it'll be set up exactly the same way. So I've finished up the thumb. So it has a thumb curl and a thumb splay, but it operates on its own. It's not influenced by any of the global hand controls. And then for the metacarpals, for these controls, I did very much the same thing, except in some cases I just took the direct channel values, so of the hand curl and index curl, and then I just multiplied them by a very, very small number. And so if you look here at this knuckle, the hand curl, you can see the moves all of them down just a tiny bit, and then the index curl moves that metacarpal down just a tiny bit, and then the same with the splay. So it goes out and in just a little bit, just to keep the palm a little bit alive while these fingers are moving around. So you can see they separate a little bit there. And you'll have to play with these numbers quite a bit to suit your character. And once you actually see this deforming, you may want to increase these numbers or decrease them. But you can see that even though, if we go back to this expression, even though we have a lot going on here, it's really just the same thing over and over, referencing different controls. So once you understand basically one of these little guys, then all of this makes sense. And you can add and remove and play around with these numbers all you want. It's all very, very simple. They're all just being added together to result in a final, whoops, don't do that, to result in a final rotation for each of these bones. So don't be intimidated when you see something like that, because you understand each of these individually, and you can work out what's going on pretty quickly. So we are done with our hand, and that means that we're done with our arm. So what I'm going to do now is I'm going to go through and clean up all of these nodes. Like all of our auto nodes have these expressions in their rotates, but all of these are unlocked. So I'm going to go through and make sure that they're all locked, make sure that the only control that's being displayed is the actual control itself. And then when I come back, we will just take a quick look and make sure that we haven't missed anything. And then we'll mirror the arm and hand parameter pane to create a right arm, a right hand. And then when we have all these parameters mirrored to the right-hand side, we'll grab all of this stuff, our entire arm and hand, and mirror it over to the right-hand side. I've gone through and made sure that all of our nodes are displayed properly, that they're named properly. They all have an L underscore in their node name. And I noticed, in fact, that these space switching nodes actually had L arm, and so I changed them to have L underscore arm. So that was these ones here. So everything is good, and we can now mirror the arm and the hand. as well as our parameters. And you could do this in either order. You could mirror the nodes and then mirror the parameters, or mirror the parameters and then mirror the nodes. I'm going to mirror the parameters first. So we have left arm, within which we have left arm, left hand, all the fingers. And if you look at the type properties here, you'll notice that there's a lot of parameters. And duplicating all of these, I mean, we could just select them all and hit D and then rename them all. But this would be, well, it would be horrible because there's lots of them. So I wrote a little script, and I've installed it with our others here in our rigging shelf. And it's just called mirror HDA parameters. So if we edit the tool and have a look at what that has in it, it's reasonably simple. It's doing just a few things. It's getting the selected node and finding its definition, because it's an HDA. And then it's making a copy of the parameter template group. So that would be, all of these parameters. And the way in which you edit parameters in an HDA is to make a copy of the templates. And then you modify the templates, and then you set them back into the definition. So that's what we're doing here. We're making a copy of the template group, and then the user is asked through this read input function to name a folder. So that could be master or spine or whatever. In our case, it's left arm. And the default here is left arm, but you could change that anytime. And then it asks for an old prefix and a new prefix. So in our case, and the most common case is left and right. So given those things, it goes through that copy of the parm template group, and anywhere it sees L, it'll change it to an R. And then it inserts that change into the copy that it made of the parameter template group. And then it sets the parameter template group for the definition to be that modified copy. And then it saves the HDA. So we can see how that works. If we go up, select our HDA, click Mirror HDA Parameters. So here it asks us to name a folder. So we're going to give it left arm. We're going to say OK. It asks us for an original prefix, that would be L. Asks us for a new prefix, in this case R. And it's done. So you can see that it created another folder called right arm and recreated all of those controls, even all the fingers. So we didn't have to do any of this work. And if you hover over any of these, you'll see the little pop-up. And sure enough, right R underscore hand control. So that will be true for all of these things. The one that it didn't do is this left arm, because left is being spelt L-E-F-T, not just L. But that's no problem. We can just go and find it. And we can just change it to R and right. And if that had been L underscore or L arm, it would have changed it automatically. But since we spelled it out for this folder, it just ignored it. So that's done. So now we have a left arm and a right arm, and we don't have to recreate any of these controls. So now we can go inside and mirror the actual nodes themselves. So in the viewport, I'm going to select mirror, and then very importantly, we want to change this new prefix. So our current prefix is L. We're going to do R underscore, and it's going to remove the old name up to underscore. Mirror plane is YZ, which is fine. And then I'm going to select the nodes in the network, not in the viewport, because any nodes that are not displayed, I won't be selecting. So I'm going to select these two large net boxes, so the arm and all the hand nodes. And in the viewport, you can see that it's giving me a preview mirrored properly. So then, again, in the viewport, I'm going to right-click and select Accept Selection, or I can hit Enter. And Houdini is going to work for a bit. So at this moment, I'm not going to touch anything because I want to see what's going on. So the arm looked like it mirrored properly, but the hand is sitting over here. So there might be something wrong. And in the network, it recreated the two net boxes and filled them. So that's all good. So what I can do is take this network box and put it on the right-hand side, and this one just below it. So the reason that this seems like it didn't work is that the location of this hand is being determined by a constraint. And sometimes using the mirror tool, which recreates all of those constraints, sometimes the offset on the constraint won't recook. So one way you can fix this, even though technically it's not broken, it's just appears to be broken. One way you can do it is to save your HIP file and then reopen the file. And by reopening the file, Houdini will cook all of these nodes properly, and that will recook the offset, and it'll be fixed. But we might try just going into our right-hand bone offset, has that constraint. If we go inside, and we might be able to update the offset. Oh, so our controls went over, so that's good. And we can go back up, and we go over here to our bones, right-hand bone root, which also has a constraint. Dive inside, and again, update the offset, and the bones popped over to the right-hand side. You'll notice that the recreated constraints network is still pointing, or the node is still called left arm bone 2, but it is actually pointing to right arm bone 2. So you might see one or two of these little things that didn't get renamed right arm bone 2 or something. But just look for the target, and you can see that that is correct. So we can go up. And now if we select one of our right-hand side controls and test it, we can see that the rig is working, but it's translating on both sides. So why is that? The reason is that the mirror tool has done almost a complete job. It's mirrored all of our nodes and all the relationships, except it has not changed the channel references. So all of these nodes are still being driven by the left arm parameters. So we need a way to change that. And unfortunately, the way to change that is to either build your left arm and hand and then mirror and then promote all of these individually, like promote all the left-hand side and build your interface, and then do the same again on the right-hand side. But we don't want to do that. It just takes too much time. So the better way is to do as we have done, build the interface for the left arm and the left hand, then mirror those interface controls, mirror the actual nodes, and now we'll use yet another little script that I'll be providing. I call it opchange, and the reason I'm calling it opchange is because it uses an H script expression called opchange. And opchange is extremely powerful, and so you have to be fairly careful in how you use it. And it does pretty much what it says. It will change something. And what we're changing, you can see in this little example here. If I was in the text port, if I go to Window, text port, and I say help opchange, I'll get a big help description. So you can see there's lots of different parameters for the type of change that you want to make. And very simply, it searches and replaces text in parameter values. And you can specify the type of node, you can specify the node names, their paths, and then this -I option, which is one that we'll be using, allows you to search for partial words. So in our case, we're doing partial word left underscore. So look for left underscore and change it anytime you see it anywhere to right underscore. And then we're also using the dash N option, dash capital N, and that means node with a full path. So based on the selection, we're going to prompt the user for an old prefix and then a new prefix. And then for each of those nodes, so we're going to build, for each node we build a path. We do op change capital N plus that path, so the path to the node. Then we're going to do a partial change, and we're going to change the old prefix to the new prefix. So let's see how that works. Let's just do it on one node to make sure. So currently, right arm bone goal control, this guy here, is being channel referenced to left arm IK translate X, Y, and Z. So we'll select that node. We'll click op change. It will ask us for an old string, and the default in this case is left underscore, which is what we want. The new string is right underscore, which is what we want. And there we go. If you're on Windows, you'll get a little console pop up there. So it's gone and looked for any left underscore, and it's changed it to right underscore. And so now, when we move it, it moves on its own. And if we pop up the parameters, we can go to the right arm, and there we go. So that's exactly what we need to do, and we need it to do it to all of these nodes. So I can simply grab everything in these net boxes, op change, left underscore, right underscore. We get a little console pop up, and now all of these should be just fine. And we can have a look at our hand. So we got right hand curl and the left hand isn't doing anything. So that's it. We have successfully mirrored our entire right arm, our left arm and left hand to the right arm, and turn those on, make it look the same. And you'll notice that the default mirror color is, for at least for green, is this kind of purpley color. You can change that if you want. I'm going to leave it as it is. So the next thing that I'm going to do, I'll pause the video and come back and show you what I've done, but I'm going to go through and make sure to clean all these nodes. You can notice that many of our controls still have unlocked parameters. So I'm going to go through and lock what needs to be locked and make sure that nodes that don't need to be displayed are turned off. And then after that, what we're going to do is set up that automatic shoulder control so that when I raise up the arm, this shoulder will move a little bit with that. I've gone through and made sure that all of the nodes in both the left arm and left hand, right arm and right hand, are displayed properly. The ones that shouldn't be displayed have been turned off. Then I've gone through and selected all of the controls and locked all but the promoted parameters using the lock all script that we have. And now we can set up these little automatic animation controls. And these are optional things. Sometimes animators prefer to do these things manually, but sometimes they like to have a bit of automated control. So the first one we're going to set up is in the when the arm is in the IK mode and we raise this wrist control, we want the shoulder to just lift a little bit. And we'll accomplish this with a look at constraint. And what we'll do is we'll take the left shoulder bone auto, which is above the left shoulder bone control, and we'll create a look at constraint between this guy and this wrist control, so that as this wrist control moves up, the auto node above the shoulder control will look at it, and so it will rotate up as well. So to do that, select, don't have anything selected actually, go to Constraints, select Look At, turn on Keep Position, And then we'll be prompted to select an object to create look at constraints. So we select our left shoulder bone auto, and in the viewport, right click and accept. And then it asks us for a look at object, and that's going to be our left bone goal control, which is this guy here. So accept that. And then it's going to ask us for a look up object, if any. And in this case, we don't have one, so we can just hit enter in the viewport. That'll drop us down into our left shoulder bone auto constraint network. You can see that it has this look at chop, and the goal is, or the target is the goal control. So the important nodes in this case, because we're going to modify these, are the look at and the offset. And the look at gives you some options for what the axis is and the up and all of that. But in our case, we want to look at this offset because we don't want 100% constraint. If we go back up and we select our goal and we move it straight up, you can see that the shoulder moves along with it perfectly. And while that's kind of cool, it's a bit too much for what we want. We want just a much more subtle lift for that. So we go back to the control or the shoulder bone auto constraint network, and we select this offset. We can use this blend parameter to blend that constraint all the way off if we want. And in fact, we'll be promoting this up to the parameters of our character here for the left arm. But for now, let's just put this at 0.2 and see the difference. Whoops. So now if we move our arm straight up, you can see that I'm just getting just a little bit of sort of sympathetic rotation in our shoulder when we move that up. So that's great. That's what we want. And then, of course, moving in any of the other axes. So if I move the hand forward a little bit, you can see the shoulder kind of rolls forward and back. So that's perfect. And again, in and out as well. So let's just promote this right away. So just here in the node path, we can right-click and say Type Properties. Go to the parameters of our soldier. So in left arm, or L arm, inside left arm, right underneath this left arm FK-IK blend, I'm going to add a separator. And then underneath that, I'm going to go inside the constraint network, grab this offset node. I'm just going to take this blend that has this 0.2 value already, which is a pretty good default. I'm just going to select it, drag it up right underneath that separator. So now it's blend, but we want that to be a little more descriptive. So we'll call this left arm auto shoulder blend. We'll hit apply and accept. Oops. Wonder what that was. Let's just double check that. There we go. So now we can go up. So that still works. But in our parameters, we have this left arm shoulder blend at a 0.2. So we can blend that straight off. And now the effect is gone. Or we can crank it all the way up to 1, and we get that exaggerated effect. So you can play with the range and the default value there, just using go to the type properties for that parameter here. You can change the range from, right now it's at 0 to 1, but you can change that here. You can also change the default after the parameter has been created by going to the Channels tab and just changing this 0.2 to whatever is best for you. All right. The next auto control that we want to create is between the shoulder rotation and the rotation of the scapula. So what we want to do is when this shoulder rotates up in Y, you can see that the scapula is following because it's a child of the shoulder bone. But we want the scapula to rotate back down in X just to fill this space a little bit better. And the way that we'll do that is with a simple expression. So we'll go to our shoulder control, and we want its Y rotation. So we can right-click and select Copy Parameter on the Y. Then we can go over to our scapula root auto, and here we want the X. So we'll just right-click, paste relative reference. So now, when we rotate, you can see that we're getting this double transformation. So select the auto again and put -1 times that expression. So now this will do the opposite. So we take our shoulder control, rotate in Y, and see that it's staying down there. And if we rotate down, you can see that it's rotating a little bit forward. So again, this current effect is probably too much. We want maybe about half of that. So what we can do is, we have this -1 to create the reverse. We could change that to 0.5, but I think I like to have the -1 to reverse the value and then multiply that by a separate number to be our blend. And now when we rotate, we get just a subtle little bit of movement in that shoulder, or in the scapula. And then we can still, because we did that to the auto, we can still select the control object and manipulate the scapula independently. And then lastly, we're going to drive the rotation of our clavicle with the rotation of the upper arm bone, so that as our arm bone moves around, our clavicle will move with it. And we'll do that with a constraint. So we'll come to our constraints, we'll go to a blend, we'll use a simple blend, just rotation, and keep position after. So the node that we want to constrain is the left clavicle root auto. Right-click and accept. And the node that we want to drive that with is the left arm bone 1. So again, it pops us down into this constraint network. And in this case, we have a simple blend that has the blend parameter. So we can use this to blend it off. But you can see that if we change this value, the offset node needs to be updated. So we can't promote this for our animators to increase or decrease this effect without having to update the offset every time. So that's inconvenient. But what we can do is use the offset node and its blend parameter. So we can promote this to blend on and off the effect of this constraint. So we can see that if we back up, if we select, even if we're in IK, and move that arm bone goes up, you can see that our clavicle is reacting to the movement of this upper bone, but it's reacting much too much. So we'll go into that clavicle root auto, into the constraint, and the offset. Let's put this at 0.05. So just a tiny, tiny little bit of influence. So now if we move this up, you can see the clavicle is just barely moving. And again, you can change that to whatever you want. And you can see also the shoulder is still moving, and the shoulder is also driving the clavicle. Great. So what I'm going to do is do the exact same thing on the right-hand side, and then I'm going to promote this blend for the clavicle offset, and also for the scapula. Instead of this hard-coded 0.5, I'm going to create a parameter to drive this. So I'll do that for both sides and come back and show you what I've done. All right, I've gone through and recreated the constraint and expression for the right-hand side. So when we raise the right arm, Shoulder moves a little bit. Scapula moves a little bit with the movement of the shoulder. And the clavicle also moves just slightly with the movement of the upper arm bone. And then in the parameters, I changed what we had before. I had a little separator here, but now that we have three parameters that we're not probably going to use very often, I made, if I go to the type properties, I made a folder in both the left arm and right arm called left arm auto, and I made its type collapsible. And what that will do is it will create this little, little plus and minus guy here. So you can just collapse that and you don't have to see those controls anymore. So it cleans up our interface a little bit. And then if the animator wants to go in and make an adjustment, they just open that up and can play around here. And then for the scapula, we had this expression, -1 times the shoulder bone control times, and we had a hard-coded, I think, 0.5. I created a parameter here called scap blend with a value of 0.5. And then I just, I'll just reproduce what I had before. So we had this value of 0.5. And an easy way to channel reference in an existing expression is to grab the parameter that you want to use and just drop it in any of these empty parameters and just say relative channel reference. And now you can copy that, delete it, set that back to the value that it had before, and paste. So that's a quick way of doing that, rather than typing it all out and possibly making a mistake. So that, I think, is it for our left arm, our left hand, the automatic shoulder, got all of our parameters, got space switching, IK and FK blending for both the left arm and the right arm. So that'll be pretty much it. Next up, in the next section, we'll be building the legs and the feet. Hope to see you then.